Hey everyone, this is Jason from organicchemistoncall.com again. What I'd like to do is briefly go over the stability of alkenes. So when we look at these two structures that I've got on the screen here, we want to think about double bonds or alkenes as more electronegative than sp3 hybridized carbon, which are just single bonds. That means that they're deficient in electron density. So what we want to notice about these two structures is really how many carbon groups, whether it's a methyl group in this case or a carbon chain, are attached to the double bonds. So in the bottom structures, we'll notice the one on the left has one carbon group and the one on the right has four carbon groups. Now carbon is mildly electron donating, so we can imagine or think about that the more carbon groups that we have attached to the double bond, the more it's going to stabilize the double bond. We can think of this as kind of an arrow. So the one on the left has one group helping stabilize the double bond, and the one on the right has four groups. And if we think about this in more technical terms, if we have one group, it's mono. If we have two, it's di. Three is tri, and four is tetra. So the first structure on the left at the top is a monosubstituted, and the one on the right is a tetrasubstituted. So the tetrasubstituted, having more carbon groups, which are electron donating, is more stable. Now what happens when we run into these two structures here, where the one on the left is a cis double bond and the one on the right is a trans double bond? Both of these are di-substituted. Well, just by looking at these, you can probably intuit or get a sense of what we're going to be dealing with here is sterics. So we can look at the one on the left, where the cis, and these two groups are in close proximity and they could potentially bump into each other and cause a problem. And that's exactly what we're going to see. So these methyl groups, although it can be deceiving when we write them on a piece of paper, are quite big, particularly when on double bond. So they actually bump into each other, and when things bump into each other, they want to move farther apart, and that starts to distort the structure slightly in this case and makes it less stable. So we could also pictorially look at this as two circular balls that kind of almost are overlapping and bumping, whereas the trans structure has them far apart, and therefore that'll be more stable. So when we talk about cis double bonds, those are always going to be less stable than the trans double bonds.